Welcome to another lecture on power generation and economics. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra, Engineering College, Electrical Engineering Department. So, previous class, we have learned that what is the power generation and economics, and what are the different types of loads are there, and how these loads are varies depending upon the demand of a consumer or industry, and we have to draw the load curve in order to take or in order to find the variation of the different load patterns. From there, we can easily calculate the daily energy produced, and we can also obtain the maximum demand for that particular day. So, these different types of load curves will give us an idea that, or a prediction that, what will be the load demand in future for that particular time. So, this is a load curve that we have drawn in the previous class. This is a load curve of 2019 year, January, of a particular day. So it will give an idea that, or a prediction that, what is the load will be there on that particular time of 2020. Yeah. So today we will discuss about the thermal, hydro, and the nuclear plant. We already know that how the energy is produced in a thermal power plant, in a nuclear power plant, and also a hydro power plant. We will give the idea how the energy is generated and the main important factor in order to find the generation of the energy is the choice of the sites for those different power plants. This is the most important criteria, how to choose the site. Depending upon that, you can economically generate the power and transmit it to the consumers depending upon their demand. So choice of site is the most important, and the number of units along with that is the most important criteria in order to generate the power, the economic generation of the power. So let's take with the thermal power. So let's take with the help of thermal power. So thermal power is generally known to us. The thermal power generation is the process of obtaining thermal energy by burning fuels such as LNG, that is liquefied natural gas, to convert into electric energy by using power generating facilities. So burning of coals, natural gases are there, other resources for the thermal power generation or the steam power generation. So steam power generation is a power generation method utilizing the expansion power of steam. Steam with hot and high pressure is generated from heat by burning heavy crude oil, LNG, liquefied natural gas, coal, etc. Means we have to, from the steam, from the liquefied natural gas or crude oil or the coal in hot and high pressure. Steam is used to rotate the impeller in a turbine which activates the generator, means connected to the turbine to generate electricity. Generator which is connected to the turbine means this high speed or the high motion of the stream, hot and high pressure stream which rotates the turbine. The generator is connected with the turbine, which in turn the turbine, which is act as a prime mover to the generator, will rotate the generator in order to produce the electricity. Steam is generated due to the means the high pressure, and the hot steam is generated due to the burning of the coals. And steam power generation uses the thermal energy which is relatively low temperature. It is called 60 degrees centigrade or lower. The process is that there is a brief diagram of the process is seen here. Brief diagram of this process. Here it is seen that all the colors are mentioned for the natural gas, water, steam, seawater, air, electricity, and LNG. So the basic process to generate the thermal power or the power from the coal is to heating up the coal in order to make a hot stream or the high pressure stream which in turn run the turbine. Turbine which is act as a prime mover to the generator, rotate the generator in order to produce electricity. This is the basic principle to find the thermal power or the stream power. And there is a schematic diagram of the thermal power is given here. This is generally known to us. It's a boiler. Their coal is carried with the help of conveyor, and there is a coal crusher where the coal is crushed, and then the pulverized coal is given to the boiler, which in turns in the stream, and the stream is taken to the steam turbine, which rotates the generator to produce the electricity, and then there is a generation. Second is the transmission of that transmission and the distribution of the energy. So our main concern is the site selection of the thermal power plant in order to these processes will be continuing. The process of thermal energy generation will be continued, but our motto is to choose the site in order to obtain the economic power generation. Again, I am repeating, in order to obtain the economic power generation, the first is the selection of the site and choice of the units. Number of units we can run in a day. That we have seen that the previous date class that which unit we can run, and now the another is the choice of the site. So the first consideration is the availability of the coal. This coal is available or not. A thermal power plant of 400 megawatt capacity requires nearly 6,000 tons of coal every day. So the main factor is that statistics say that a thermal power plant having a capacity of 400 megawatt needs 6,000 tons of coal every day. So here is the factor that in order to generate 400 megawatt thermal power plant, 6,000 tons coals are required, and the power plant should be located near the coal mines. Means we have to minimize the transportation cost. More we can minimize this type of cost for the generation of the power, because I am dealing with power generation along with the factor called economic power generation. The term called economic power generation. It's a very simple process that how economically we can generate the power, economically we can transfer to the consumer. So if coal is available and the power plant is located nearer to the coal mines, both the cost for the coal and also the transportation of the coal is minimized. So this is an important factor in order to generate the power. Our motto is to generate the power, but the important factor is, again I am repeating, economic generation of the power. Second is the ash disposal facilities. We know the burning of coal will produce ash. So the ash comes out in hot condition and handling is difficult. So this ash can be disposed into the sea or the river. So means we have to select the coal, means the thermal power plant nearer to the river or the sea in order to disposal of this ash. Otherwise, we have to carry those ash, means the transportation cost be considered here, which in terms reflect in the generation of the thermal power. So, the ash disposal facility, our second criteria, which is another fact. Third is the availability of the water. Water consumption is more as feed water into the boiler, condenser, and for ash disposal. Water is required for drinking purpose. Hence, pan should be located near the water sources that I have told. Disposal of the ash, that the previous point I have discussed. Feeding water to the boiler, huge amount of boiler water is required. That water and the condenser in order to produce the thermal power plant. So the thermal power plant must be located near the water resource and the transport facility, that all these consideration, all these factors are related with the transport, because if it is not located near the water resources, we have to carry the water. If the plant is not located near the coal availability, the coal have to be carried to the plant, and the ash that which have to be disposed, the water that have to be carried. So transportation is one of the bigger factors. Less the transportation, more less the generation, less the price of the generation, more economically we will approach towards our consumers. So the public problems is another concern, that the plant should be far away from the residential. The plant that is given should be far away from the residential area to avoid nuisance from smoke, fly ash, and the noise. So the noise that is be given here is the most important criteria. We have to concern about our public health, because the smoke, fly ash, and the noise will disturb the public mindset, public health. So we have to consider it. And another factor is the nature of the land. Many power plants have failed due to weak foundations. Land or the soil should have a good bearing capacity to withstand dead load of the plants. Means the dead load of the plants can be withstood by the land soil. The nature of the land is the another important parameter. So those parameters are related to generate the steam power or the thermal power. In order to, we have to generate the steam power or the thermal power. We have to consider those factors. We have to consider those factors in order to make economical power generation. Factors, again I am repeating that availability of the coal, as disposal facilities, water availability, transport facilities, public problems, nature of the land are the most important factors related with the power generation, thermal power generation. Now I am coming to the hydroelectric power. So what is hydroelectric power station and how it's work? This is generally known to us. I just give you an idea, just recalling your memory. As we know that the hydro means water. So generating station where the water potential energy is utilized at a high level for the generation of electric power is known as a hydroelectric power station. So main resource is the water. Hydroelectric power stations are usually built on the hilly location where the dams can be built. Means those dams can be built where we can able to store the water and convert the water storing water into an electricity. A large amount of water can be stored in a dam. In a hydroelectric power system, water head is created by construction a dam across a lake or a river. A dam will be constructed across a lake or a river where the water head is created to store those waters. Hydroelectric power station popularity is increasing day by day due to the reserve of fuel. Because we have to go for the alternative way. The coal and the oil are not the solution in order to, because as the day goes on, our demand is also going on. Our demand, as the days goes on, our demand is also going on. So in order to meet the demand, it is obvious that we have to think about the hydroelectric power station beside coal and the oils. Hydroelectric power station added importance for flood control, storage of water for irrigation, and water for drinking purpose also. So, the main resources for the hydroelectric power station is the water. To create a water dam, and we have to find the convert that storage water into an electricity. This is our main. So, this is our general overview of the hydroelectric power station. Hydro means the water. With the help of the pen stroke, that's the head point intake is given. It's a powerhouse where the generators are there, which the forces of this water which rotate the generator, and generator will produce electricity, and this electricity is transmitted to the transmission line. This is the general overview of the generating of power in hydropower. Because more and more days goes on, the generation of the hydropower energy will be increasing. Power generating of the hydro. So site selection and the factors that affecting the location of the dam of hydroelectric power plants, because we have already told that the dams are situated on the hilly areas, the top of the hills. So before discussing the hydroelectric power station, we need to know the where we should locate our hydroelectric power station. What factors we should keep in our mind while building a hydroelectric power station. So we're going to discuss few factors which are considered the most important factors. One is the availability of the water. Since water is the primary requirement of the hydroelectric power station, water availability must be in huge quantity. Such power plants must be built at a place where the water is available in a huge amount of good head as well. Means the main source for the energy from where the energy is generated is the water. So availability of the water means that water is available or not is the most important factor in order to choose the site location of the hydroelectric power plants. Second is the storage of water. There is a wide variation in water availability from rivers throughout this year. This makes it necessary to store the available water. In order to store water for constant generation of electric power, we must build dams. Dams, we all know about the dams conception where we can able to store the water, and from there we can meet our daily demands. In certain days of the year, the water quantity decreases up to a low level which can affect the generation of the electric power as well. So again, the construction of the dams, the site that we choose at the top of the hills to store the water, or in order to maintain the flow of the water, those selections are very much important because again I am repeating, generation of the power is there to meet the load demand, but the main factor is how economically we can generate the power to meet our consumers. Then the third one is the cost and the type of the land. Another most important point is the initial cost and the type of the land. The land on which the powerhouse is going to be built must be at a reasonable price. And secondary, the bearing capacity of the land. The ground should be good to withstand the weight of the heavy types of equipment. The soil can able to withstand that heavy types of equipment. So the cost of the land is the most important factor because we have to buy the land in order to develop the power plant. So if the cost of the land is minimum, so it will affect in the generation of the power because we have to add those cost of the land in order to generating the power. If it is minimum, then the generating power which is there will be minimum for the consumers, but the land soil must be withstand the capacity of the plant because there are different types of equipment. Those are there. The heavy equipments must be withstand by the soil. Transportation facilities. So this is one of the important facilities. The site selected for the important factors that the site selected for the hydroelectric plant must be accessible on the transport facility so that the heavy machinery could easily be transported to the station. Those machineries must come very easily to the transportation by the transportation. Minimum the transportation facilities means the transportation facilities means the transportation costs minimum it will reflect in a minimum way on the generation of the energy. So those four factors are very much important in order to select the site for the hydroelectric power plants. The first one is the availability of the water, second one is the storage of the water, third one is the cost and type of the land, and the fourth one is the transportation facilities. Those facilities must come in the consideration while we will design a hydropower plant. Again, I am repeating the most economically we can choose the site, most economically we can generate the power for our consumers. Third one is the nuclear power plant. Basically, the nuclear power station or a coal fire or natural gas power stations are very similar in terms of power generation principles and major facilities. They all make use of heat from their fuels to create steam that we have learned for the thermal power plant. That turns the turbine and enables the station generator to produce electricity. That we have done. The main difference is the kind of fuel that we are used for the thermal power plant for the nuclear power plant. Nuclear power plant is generated mainly through the use of uranium. The process that produces heat in a nuclear power station is called the fission. The fission generates the heats. Here the heat is generated by the fission, where for the thermal power plant the heat is generated by the burning of coal oils which created a high pressure in the stream, which in turn move the turbine, which is act as an prime mover to the generator, which in turn move the generator to generate electricity. Here, in case of the nuclear power plant, the process is same for the turbines and also the generators, but the heat that is generated by the nuclear fission reaction of the uranium. The fission generates the heats in the reactor and the heats up the water surrounding the fuel rods. The water will then be changed into the streams to turn the turbine and enable the generator to produce electricity. Only the difference is the generation of the heat, where there is the burning of the coal or the oil in case of thermal power plant will generate the heat which in turns heated up the streams. Here in the nuclear fission here in case of the nuclear nuclear power plant, the heating purpose is done with the help of the nuclear fission reaction of the uranium, which generates the heat in the reactor and heats up the water and the surrounding fuel rods, and then this water will be changed into the streams, and which enables the turbines to generate or the produce the electricity. The generation, the main difference is the kind of fuel that we are used. So this is a basic diagram of nuclear power generation. So it is seen that produce heat energy through the nuclear fission, power generation, transmission and distribution of electric to the consumers. So reactor in the nuclear island. The reactor contains this is the reactor. The reactor that is contains the arrow sign is given for the reactor. It contains uranium which undergoes a nuclear fission process that splits into atoms and produces heat. The heat in the fuel rods raises the temperature of the water running in the nuclear power stream system and turns the water into the stream. So the reactor purpose is that there is an uranium there and the nuclear fission reaction is there done for the nuclear fission reaction, which splits the uranium into atoms and produce heats. The heats in the fuel rods that raise the temperature of the water and running in the nuclear powered steam system and turns the water into a stream. Second part is the turbine. The turbine converts the energy brought by the steam into a mechanical energy. Means it is act as a prime mover to the steam energy. It is converted into the mechanical energy with the help of the turbine. And the generator is connected with the turbine, converts this mechanical energy into electric energy. And electrical transformers are generally known that the step up through the electrical transformer, the energy electrically, and feed it to the transmission network that distribute power to the outside. So the four processes there. First of all is the nuclear fission reaction in the nuclear reactor, where the fission reaction is done on the uranium and is split into the atoms to produce the heat. This heat generally goes to the fuel rods where the water is flowing, and this heat which is heated up the water to produce a stream. A stream that is now sent to the turbine, where the energy brought by the steam, the heated stream will be converted into a mechanical energy. The turbine is connected, which is act as a prime mover to the generator, and the purpose of generator is converted that mechanical energy that is transmitted from the turbine to the electrical energy, and followed by the transmission process. Those energies, there is a step up transformers are there, which is also transmitted the generated energy, electrical energy, and into the transmission networks, and that distribute the power to the outside. So same, the site choice are same. So whatever we have learned today, we have learned about the thermal power, about the nuclear power, among the hydropower, and how it is hydropower and how it is generated, thermal, nuclear, and the hydropower. And what are the sites? That's most important factor is the choice of the sites and also the factors. For that purposes, if those factors can be minimized in order to select the size, yes, we can generate the power, but the main motto is more economically we can generate the power, more economically we can generate the power, more economically we can transfer to our consumers depending upon the load variation. So choice of the sites is the main important factor, and also the number of units. So those factors, can we minimize those factors? Is so that we can go through all those factors, but more economically we can approach towards those factors, more economically we can generate the power. This is our main. Thank you.